Hi, I'm Selena Rekov, and I'm going to talk today about perfluoroketonoic acid remediation. So, perfluoroketonoic acid, PFOA, is one kind of emerging pollutants. But what are emerging pollutants? Emerging pollutants are pollutants that they have a continuously entering in the environment through various sources, and they have potential risk to human and environmental health. So, for example, the pharmaceutical personal cares, microplastic, synthetic and natural hormones, and pesticides, they can be emerging pollutants, and they are persistent chemicals. So that means they do not degrade naturally. And this this these pollutants, they're often lack intervention values, neither regulated analytical methods. So PFOA, right, is considered for one of the forever chemicals that's very persistent. It does not break down naturally, and mainly is because this carbon-fluorine bond that is very strong, the strongest bond, chemical bond, actually. Okay, right. Okay, so you have a contamination, right? But what can we do to treat it? So we have different remediation methods for water and soil remediation. I'm going to talk here just a few remediation. For example, bioremediation. The bioremediation technique uses microorganisms to break down or transform contaminants into less harmful substances. Bioremediation. And chemical oxidation uh, usually is related to redox reactions. So they will transform the contaminant to break it down or transform into less harmful substances. Physical remediation, so can be, for example, soil washing, adsorption, and soil vapor extractions. They are kind of physical remediations. Physical remediations do not break down the contaminant, just changing from water or soil to another system, right? And also you have a thermal remediation. This remediation here involves using heat to mobilize and remove volatiles and semi-volatile organic compounds. Right. Remediation, right? With remediations use bioremediation technique use microorganisms to degrade or transform contaminants into less harmful substances, right? In a study here, Ha et al. 2025, using microalgae to treat PFOA. So they use the bioremediation of PFOA by acid quadricauda algae. This mediation here involves redox reactions and and that produce reactive oxygen species should degrade the contaminants. Right. So there's a study here that using microalgae to treat, right? Got 58.2% of PFOA removal in 24 hours treatment. This technique here, like bioremediation, so the main advantage is the cost effect in environmental friendly technique, right? And the main disadvantage is because it requires a long treatment time. All right. So the next study here, the next technique is electrochemistry. Electrochemistry remediation uses electrical currents to remove or degrade contaminants, right? In this study here, Lee et al. 2022 got 51.7% of PFOA removal. And this treatment here, right, that was electrochemical destruction, disruption, and mobilization of PFOA. This one also investigated treatment of PFOAs using reactors with saturated soil. You have here the anode side, right? That it happens the oxidation. And here the cathode that's happy the reduction. So this technique here got 51.7% of PFA removal using a low constant voltage in the direct current of 24 volts. And 467 to from 467 to 609 milliamperes. And the determinant of this study here, the best conditions was obtained in 10 days treatment using these conditions that got this removal here. Okay, so the main advantage using electrochemistry remediation is high efficiency. It's high efficient to treat different pollutants. And the main disadvantage is because this technique requires a high energy consumption and consequently also can be expensive because it will require higher energy consumption, right? Okay, right. So the next one here, you have this paper here that uses bioremediation with electrolysis. So that technique here is use two techniques, bioremediation and electrolysis. So bioremediation, know that it uses microorganisms to degrade or transform pollutants into less harmful or harmless substance, right? And the electrolysis, that this process using electricity to drive non-spontaneous redox reaction. So for the PFOA removal here, we had this condition, this treatment here, use bacteria, anaerobic bacteria, right? And electrolysis to do a redox treatment here. Still had a redox reaction also. And the best removal here was obtaining removal efficiency of PFOA was 77% of PFOA in 80 days treatment. So it was required a long time in treatment, right? So, okay, so bioremediation can be a cost-effective treatment, right? And environmental friendly, and electrolysis may require like high energy consumption. So need to balance the cost effective, right? And then the next treatment here is adsorption. So this paper here, Zhang et al. 2021, used aluminum as absorbent to remove PFOA from water. And the highest removal was obtained 97.4% of PFOA removal in 24 hours treatment. So we have here the aluminum-based drink water treatments, right? The aluminum here would stop the bad PFOA. And the best conditions here, so the study here studied the aluminum efficiency to absorb PFOA in different pH conditions. The best conditions were obtained using low pH system, right? Okay, so the main advantage for adsorption technique is a high efficiency and reuse capacity. So it's this aluminum here. You can use several different cycles to do the treatment, right? To do the adsorption treatment. But this technique here does not degrade the contaminant. It's just removing from water or soil to another system, right? And then the last treatment here, let's talk about the advanced oxidation reduction process. So this treatment here, okay, is a redox reaction, right? But the difference here is because we have radicals, will be activating the reactants to promote radicals. So, okay, this technique here is a generation of a highly effective, highly reactive oxidizing species such as sulfate radicals, hydroxyl radicals, and reducing species such as superoxide radicals. Actually, superoxide radicals can sometimes work as behave as oxidizing agents, sometimes as reducing agents, but it's more efficient. Usually, the superoxide radicals they are more efficient when they are working as reducing agents. So the three reactants used in this process, you have persulfate, hydrogen peroxide, and ozone. And the main advantages of this technique is highly efficiency degradation. And this technique here can be used coupled to another remediation technique. And the main disadvantages here for this treatment is can be expensive to operate and maintain, and there's a high probability generated by products required further treatment. All right. Okay, so we still talk about the advanced oxidation reduction process. So it's called advanced because it will be faster than normal reduction reactions, because here you'll be activating the reactants to make radicals. For example, here, to make oxidizing agent radicals, for example, one technique is using persulfate ion with heat to make the sulfate radical. Another one is activate the persulfate using UV light to make the sulfate radicals. Another one is still persulfate in alkaline conditions. Or also heavy metals, so using the persulfate or hydrogen peroxide with metals will make the persulfate will make the sulfate radicals, and the hydrogen peroxide will make hydroxyl radical, right? So here, this technique here, they are to make oxidizing agents. So, and then, for example, here, right? You have hydrogen peroxide with metal to make this hydroxyl radical. So to make reducing agents, if you use this hydrogen peroxide in excess, right, in the ending of this process, we will make superoxide radical. All right. And that is reducing agent. So this study here was published in 2016, studied hydrogen peroxide in the persulfate activated by iron modified atomite. So in that case here, use a heterogeneous system to remove the PFOA, right? And here was a diatomite with iron precipitating the surfaces. So like the hydrogen peroxide or persulfate, they were activated by the iron, sorry, by iron, right, in the surface here to produce, reducing species like superoxide and oxidizing species as sulfate and hydroxyl radicals, right? So this technique here, this study here, got highest removal conditions was using any high concentration of hydrogen peroxide to produce the superoxide radical, right? And the best condition, the best removal was obtained in high concentrations in 6 hours treatment, and the best condition obtained 83% removal of PFOA. Okay, but which method is better? So actually, the best choice depends on the type of the contamination. So, okay, I showed here, right, 5 different techniques about the PFOA remediation. But to choose to any kind of contamination, it's okay. What remediation is going to be better? Need to know the type of contamination, the pollutant concentrations, and understand the physical chemical properties of the pollutants will be is crucial for an effective remediation, right? And among the studies presented here, right, 5 articles, the best treatments were the one that use adsorption and advanced reduction process here, right? Okay, in ethical considerations. So minimizing exposure. So you know the PFOA and other chemicals, right? They have potential risk to develop, including develop effects, increase the risk of certain cancer, right? So the first thing, minimizing exposure of PFOA, not only PFOA, and another pollutant, right? Then the next point here is sustainability. The methods to treat pollutants should be environmentally sustainable, minimizing their creation of new pollutants or waste. Right? Cost accessibility. We needed to evaluate the cost, right? Like the cost effective conditions of each treatment. Okay, and there are risk of secondary contaminations. So during the removal process, such as disposal of contaminated material or release of other pollutant, we may have a second contamination in the process. Related to prevention means to prevent future PFOA contaminations or on another pollutants by choosing another products that don't have contaminants, these contaminants. And related to added consideration to regulation, so regulations are needed to control the production, use, and disposal of PFOA and other PFAS chemicals. All right. So related to the findings to relevance of the findings to everyday life. So you know the PFAS can be found in food packing, right? Non-stick cookware, firefights funds, etc. So we needed to choose the products for our consumption, right? Avoid these products that will have PFAS. Drinking safe water. So PFOA is a common contaminant in groundwater and drinking water process. So we needed to make sure you are drinking safe, safe water, right? Relate to have protection. So you know the long-term PFOA exposure is associated with several health issues, not only PFOA, but many actually emerging pollutants, right? So in an example, PFOA is part of the forever chemicals, right? Because it does not break down naturally. And our responsibility is to protect and manage the environment, right? In Genesis 2:15 says, the Lord God took the man and put him in the garden of Eden to work it and take care of it. So God created the world for us to take care. So what can we do, right, to help protect the environment? So you can use the recycling, right, reducing waste and reusing materials, conserving water, avoiding waste, choosing sustainable products, right? You can help using different things. Those, okay. So these articles here were the articles that I showed the results PFOA removal, right? They use remediation, PFOA remediation, different techniques, right? Thanks for watching. All right.